In this lesson, we'll be talking about coordinate rules for dilations. By the end of the lesson, you should be able to dilate a figure without drawing it and find the scale factor. So congruent versus similar. Congruent means they are exactly the same size and shape. Their angles are the same and their sides are the same. And you can see there the symbol for congruent. Similar is the same shape but not necessarily the same size. So the angles will be the same because a 90-degree angle is a 90-degree angle. It doesn't matter how big or small the figure is. But the sides are proportional. So to dilate without drawing, the rules are you multiply the x and the y by the scale factor. So the rule will look like xy goes to 2x, 2y. This number will always be exactly the same for both of them because you can't multiply just by x by a number and not y. Your figure won't be proportional. So for example, parallelogram ABCD is dilated by a scale factor of 2. Find the coordinates of the vertices of the image. So point A is at -4, 3, and point A prime would be -8, 6. Point B, the original, is 1, 3. B prime would be 2, 6. I'm multiplying the x and the y by 2. C would be 0, 1, goes to 0, 2. And point D is from -5, 1, goes to -10, 2. So examples, using the figure, identify the changes and write the rule. So looking at this figure, you can see that the blue parallelogram is big, and then it goes to the gold one, which is smaller. So it's going from A to A prime, so it is a dilation, but it's a reduction. So what's the scale factor? Well, if I look at the original A, ordered pair, it goes from -2, 4 to -1, 2. And B goes from 4, 4 to 2, 2. And C goes from 2, -2 to 1, -1. And D goes from -4, -2 to -2, -1. So you should be able to see that all of those numbers were cut in half. So the rule is going to be xy goes to 1/2 x, 1/2 y. Notice they have to be exactly the same. So in the table, complete the original coordinates and coordinates after the dilation and write the rule. So this time we can see the original is the orange triangle because it does not have prime symbols, and the new one is the prime. So the original coordinates is 0, 2, 2, -1, and -2, -2. So the new ones, the one with the prime, is 0, 4, 4, -2, and -4, -4. So what's happening from the original coordinates to the coordinates after the translation? You should notice that everything is being multiplied by 2. So my rule is xy goes to 2x, 2y. So if we look at these ordered pairs, we've got 3, -6 and 9, -18. You should be able to see that they're getting larger by a factor of 3. And this one, it's going from 3, -6 to 1, -2. You should be able to see that it's getting smaller, so we're multiplying by 1/3, which is the same as dividing by 3. That's a reduction. Here we're going from 4, 9 to 12, 27. Multiply 4 times 3 to get 12 and 9 times 3 to get 27, so that's an enlargement. This one we're going from -9, 9 to -3, 3. It's getting smaller. We're multiplying by 1/3 or dividing by 3. Here we're going from 2/3, 2, 3 to 6, 9, which means we're multiplying by 3. It's an enlargement. In this one, 3, 9 to 1, 3, so it's getting smaller, and we can multiply 3 times 1/3 and get 1, or divide by 3, same thing, it's a reduction. In this one, we're going from 5, -1 to 15, -3. It means we're multiplying by 3. That's an enlargement. This one's going from 6, 3 to 2, 1. So 6 divided by 3 is 2, or 6 times 1/3 is 2. That's a reduction. Congruent figures have angles that the angles are always exactly the same. Are the following similar or congruent? Rotations are congruent. The figure didn't get bigger or smaller. It stays exactly the same. It just rotates. Reflections are congruent. They're exactly the same size. They're just on one side or the other of the x or y axes. Translations are congruent. They're just sliding. But dilations are similar because they're getting bigger or smaller.